Good morning, good afternoon, good evening, depending on when you're watching this. It's your boy, Mr. Malachi, and I'll be taking you through fraction equations. So, how do we go about solving these? I'll take you through a couple of examples, and right at the end of the video, I'll give you the procedure of solving every single equation, fraction equations. And at that point, I think you would have picked up on that procedure. So I will explicitly write it out for you. So on that note, let's jump right into the first example. We're given x divided by 2 minus x divided by 3 is equal to 2. So how do we go about solving this? First thing is we need to establish what the lowest common denominator is. So looking at this expression, I see two denominators. I see the denominator of 2, I see the denominator of 3. Can those guys divide into each other? The answer is no. So if those guys cannot divide into each other, the lowest common denominator will always be the multiplication of those two numbers. Only if they cannot divide into each other. So in this case, 6 is my LCD. What do I do with that LCD? I take each fraction and I multiply it with the LCD. But the way I write the LCD, if I'm multiplying it with the fraction, I write it as a fraction. 6 over 1 is the same as a 6. So I'm going to write it as a 6 over 1 because I'm multiplying it with the fraction. Then I do the same with the next fraction. Remember, we are multiplying it with every single term that is in our equation. So the 2 is also going to be multiplied by the LCD. Then at this point, I cross multiply. So what I do, I ask, what is 2 divided by 6? I get a 3. That 3 will times this x, giving me a 3x. Then I ask, what is a 3 divided by a 6? It's a 2. That 2 will times with that x, giving me a negative 2x. Then what is a 2 times a 6? It's just a 12. Then at this point, you just subtract those, and so x is equal to a positive 12. And there we go. That is just how easily you solve these type of questions. Let's look at the next example. All right, so for this next example, what we're gonna do is, again, we're gonna need to find what the lowest common denominator is. So now have a look. Between the 2 and the 4, if the 3 wasn't there, between the 2 and the 4, since the 2 can divide into the 4 would have been my LCD. I hope that makes sense. If the smaller number can go into the bigger number will always be your LCD. But since we don't just have a 2 and a 4, 2 and a 3, a 2 and a 4, we have a 2, 3, and a 4. So between a 4 and a 3, what would be my LCD? So between a 4 and a 3, since those guys do not divide into each other, I would have to multiply them together to get the lowest common denominator. So what do I do with that? You do the same thing that you did in the previous question. You times it with every single term. So the LCD times the first fraction, the LCD times the second fraction, and lastly, the last fraction times the LCD. I hope you can see it. I'm even color coding the LCD multiplication. So at this point, you cross cancel. 4 goes in there once, 4 goes into 12, 3 times that binomial there. So 3 times that binomial, you leave it like that. I'll come back and do it in the next step. 3 divided by 12 is just a 4. This 4 needs to multiply that binomial. Again, I write it like this, and I'll come back and evaluate that binomial. Where is this negative coming from? It literally just comes from up there, right? Then this last one, 2 goes in there once, 2 goes in there 6 times, 6 times a 1 is just easily a 6. Then at this point, every single time, if you've done your LCD correctly and you've multiplied correctly, this equation will always be a linear equation. At this part, you will always have a linear equation popping up. So that's an indication if you're doing the correct thing. So how do you solve that linear equation? I implore you to try it yourself. You just distribute the 3 plus a 6. You distribute this -4 there, you get a -4y plus a 24, and this is all equal to a 6. Then you would collect your like terms. I would leave the 3y minus the 4y this side. This is a 6 minus a 6 minus a 24. Hope you can see what I'm doing there. So I'm taking this 6, which was a positive. I'm writing it as a negative there. I'm taking this 24, which was a positive. I'm writing it as a negative on that other side. Right? Then at this point, we could just easily do our like terms. So on this side, we get a negative y, or 1y. Then on this side, 6 minus 6 is a 0. Minus a 24 is a minus 24. Divide by -1, divide by -1, and so y is equal to a positive 24. And there we go. Very easy. Again, find your LCD, take that LCD multiplied with every single term. Then after that, your fraction should go away after cross multiplying. And then you just easily solve it like a linear equation. So let's do another example. All right, so for example 3, we're given this guy. And what we will notice that what is different with the previous examples is that now we have a z in our denominator. So we have a variable in our denominator. So let's establish what our LCD is. So between the numbers, I can see that the 4 and the 3 can divide into a 12. So the 12 would be my LCD. The smaller numbers can divide into the bigger number. The bigger number is your LCD. But now we have a Z there. So the question is, should we take it out or not? And the answer is yes. You always need to take it out as a lowest common denominator. So even if the 12 was the only one that had the Z, you would still need to take it out as a lowest common denominator. So even if one of them has that Z, we would actually have to take it out as a LCD. So what do we do with that? The same thing. We times it with the first fraction. We times it with the second fraction. And remember, I write it as a fraction as well. We times it with the 4. And for this, I don't need to write it as a fraction. I'll just write it as a 12. And we times it with the last fraction. And that is a 12z over 1. So at this point, I just cross multiply. 4 goes in there once, 4 goes in there 3 times. This 3 and the z are going to multiply the 5, which gives me a 15z. 3 goes in there once, 3 goes in there 4 times, but the z's in this case cancel, so it's just the 4 times the 2, which is just easily an 8. 4 times the 12z is a 48z. Then 12 goes there once there's all, z and z cancels. So you're essentially left with the 1 that is multiplying this binomial. But how do I represent it? Since I have this negative there, I write a -1 with the binomial inside of the bracket. So you're sitting at home and you're asking yourself, but why, Mr. Malaji? Why can't we just write the z plus 8 or the negative z plus 8? Because this negative here belongs to both the 8 and it belongs to the z. So you just allocating it for the 8 would not make sense. It would belong both to the z and to the 8. So what do? You collect your like terms now. I'm going to keep everything the same, and I'm going to distribute that negative 1. Negative 1 times z, negative 1 times negative times 8, negative z, negative 8. Then collect your like terms. I'm going to collect all the constants onto the left hand side. So 8 plus the 8, and I'm going to collect all my variables onto the left hand side. So we have something that looks like that. This gives me 16. This gives me 32z. And in your final step, you just divide both sides by 32. So z is actually equal to a half. There we go. Very easy. I hope you guys are seeing what's happening. I do want to do 3 more examples where I am actually having a binomial in the denominator. So let's look at those and see how we're going to solve those. All right, we're given this next equation in front of us. And what we are noticing is, again, we have these binomials in our denominator. We have a p minus 1 and a p plus 2. So what I want to remind you is those denominators look something like this. If they were numbers, they would look something like this. They would not be the same. One would be a 2 and one would be a 3. And what would we do for the LCD of those two? We would multiply them together to get a 6. So that's the same logic there. Since those denominators are different, how do we get our LCD? We just multiply each of those binomials altogether, and that is our LCD. Then what do we do with this? We multiply it with every single thing. So first fraction multiplied by LCD. Second fraction multiplied by LCD. This part should be very easy, guys. You just literally just copying down what the LCD is, and the 2 multiplied by the LCD. Hope that makes sense. Then now the brackets are going to cancel. P minus 1 with the P minus 1 cancels. So this P plus 3 and this P plus 2 need to multiply. How do I represent that? I need to represent that as 2 brackets, 2 binomials that are multiplying. And I'll come back and FOIL it later. Then for the second one, the P plus 2 and the P plus 2 multiply. So these 2 brackets are the ones that are going to be left multiplying. Sorry, the P plus 2 and the P plus 2 cancel. So the P minus 1 and the P minus 1 are going to be left multiplying. So we have a P minus 1 that is multiplying a P minus 1. Then the last guy, there's really nothing we need to do there, but leave it like this and come back and multiply those brackets out. So at this point, I hope it's making sense. What we need to do now is we need to FOIL these brackets. FOIL, remember, first, outers, inners, and lasts. So P times P is a P squared. P times 2 is a 2P. The 3 and the P is a 3P. And the 3 and the 2 is a 6. Then I'm doing the P's, this next bracket. P and a P is a P squared minus P plus 1. This one, I'm going to FOIL it. I'm going to keep my answer in brackets so that later on I can distribute that positive 2 outside. So if I FOIL it, is a P squared plus 2P minus P minus a 2. Then in my next step, I want to distribute that 2. But before I do that, let me collect some like terms here. I have a p with a p squared there. Those add to give me a 2p squared. What else do I have? I have a 2 plus a 3 is a 5. Minus a p minus a p is actually a 3p. And then a 6 with the 1 gives me a 7. There we go. Then on this side, I'm going to do my like terms first. So 2p and the negative p give me a p. And then I'm going to distribute my 2. So let me distribute my 2. Let's see how that looks like. P times 2 is a 2p squared. 2 times a p is a 2p. And a 2 times a negative 2 is a negative 4. Then at this point, you just collect your like terms. So I'm going to bring all the p's onto the left-hand side, even the ones with the squared. So I have a 2p squared plus a 3p minus a 2p squared minus a 2p. Then on the left-hand side, on the right-hand side, I have a negative 4 that is subtracting a 7. Then what I notice that's happening, these 2p squares cancel, and a 3 minus a 2 is just a p. And that gives me a negative 11. So p is actually equal to a negative 11. So there we go. I hope you're seeing this. And then this, even though this was a bit long, but the procedure didn't change. We always find our LCD. We always multiply everything with our LCD, cross multiply, and the fraction will go away, and we solve that linear equation. Hope that makes sense. Let's do 2 more. I want to look at the ones that have a denominator, but we need to actually factorize that denominator. So let's look at some of those. All right, so for this next example, we notice that in this denominator here, we have what we call a trinomial. So we need to first factorize that trinomial. Here, I notice that this is a highest common factor that I can factorize there. So let's do those first before we take out our LCD. So again, if you can factorize your denominator, that should be your first step, factorizing that denominator. So these factors of negative 2 that add to give me a negative 1 is a negative 2 with a positive 1. For the second one, I just take out a 2. I'm left with an x plus a 1. And the last fraction, there's really nothing we can do there. Then now it should be easy to see what is our LCD. So we have this x minus 2 bracket that needs to come out. We have this x plus 1 bracket that needs to come out. And we have this 2 that needs to also come out. So I put the 2 in front there. So I've established what my LCD is. I do need to multiply everything with that LCD. So the first fraction times your LCD. This is quite a big LCD, so make sure you have enough space on the page to fit the whole fraction or the whole equation there. Second fraction times the LCD. Right? And last fraction times the LCD. Just gonna write it underneath there because I'm running out of space, but I do need to know that it's at the top. So this is all divided by 1. All right, And let's cross multiply. Brackets are going to cancel. X minus 2, x minus 2. X plus 1, x plus 1. We're left with just the 2 times the 2, which is just a 4. For the second one, the 2 and the 2 cancels. X plus 1, x plus 1. So we're left with this 2 and that bracket there. So how do we write it? It's a negative 2 with that x minus 2 bracket. And for the last one, x plus 1, x plus 1 cancels. We are left with this guy that is multiplying a 1, which just gives us that bracket there. Then at this point, we just need to distribute and collect our like terms. So again, I implore you to try this out yourself, and then you can always mark by fast forwarding the video. And yeah, then collect my like terms, the constants onto the left hand side, the variables onto the right hand side. Then this gives me not an 8, sorry, a 12. And this gives me a 4. And if you divide by 4 on both sides, x is actually equal to 3. And there we go. Very easy, very digestible. So again, we're going to do one more example. And yeah, at this point, you should be seeing the consistency and what we keep doing. That's what I want you to pick up on. Pick up on the procedure, what we keep doing for each and every one of these type of things. So let's do one more. All right, so for this last one, we also do need to factorize those denominators. Actually, in this case, I think we only need to factorize this first one here. It is a trinomial again. So let's do that. We're going to keep the numerator. Factors of negative 8 that add to give me a negative 2 is a negative 4 with a positive 2. So that's how it looks factorized. But what I'm going to do is, actually, this is a very brilliant question. I'm going to change the sign here. I'm going to apply something called switcheroo. I'm going to change that sign there, make it a positive, and what I'm going to do is I'm going to swap these guys in the denominator. So again, change the sign and swap the guys in the denominator, and you'll get an x minus a 4. Hope you see what's happening there. Another way to think about it is that a negative 1 is actually distributing inside there. And if a negative 1 times this with the 4 gives me a negative 4, negative 1 with the x, negative x is a positive x, and all I'm doing is just rewriting them like this. So basically we are distributing the x to the denominator. That's one way to think about it. Then the last guy, I'm also going to swap those guys around. But when I'm swapping those, I don't need to change any sign. So this I'm just going to write as x plus 2. Again, why am I not changing the sign there? It's the same as a 2 plus 3, which is the same as a 3 plus 2. Swapping those guys around does not really affect anything. So now that it's factorized, then I can establish what is my lowest common denominator. It's going to be this bracket, x minus 4 bracket. And it's going to be this bracket here, x plus 2 bracket. And we only need to account for it once. We don't write it twice because there's two x plus 2 brackets. Or we don't write it twice because there's two x minus 4 brackets. We only write it once. So taking it out once, you've accounted for it, even if there's 2 or 3 of them in the question. All right, then the same thing. I think at this point you can see what's happening. So maybe you try this question yourself and you can mark it with my answers at the end. Even the last fraction needs to be multiplied by the LCD. Okay, then we're gonna cancel. We're gonna cross multiply. So how does that look like? X minus 4 cancels with the x minus 4. X plus 2 cancels with the x plus 2, so you're left with just the 2 there. X minus 4 cancels with the x minus 4. The 5 will times with that bracket there. Please don't do this in one sum or one step. Separate it out like how I do. X minus 2, x plus 2, and the x plus 2, and the 3 will times with that bracket there. And this is what we have. Then we're just going to collect, expand those brackets and collect our like terms. So I'll do this very quickly. Then 5x minus 3x, negative 12, negative 2, negative 10. This is a 2x. This is a negative 24. This is divided by 2. So x is equal to negative 12. And there we go, class 10s, grade 10s. I hope this makes sense. I do want to, in the last 2 minutes of the session of this video, give you the procedure of what to always do when you're solving these types of questions. So let's have a look at that. All right, so this is the procedure that you need to follow every single time when you're solving these. Step number one, you need to factorize the denominator. So make sure you're factorizing the denominators. Not all of them can be factorized. If you had a look at the examples we did, I think only the last two could be factorized. So some of them cannot be factorized, so you would skip the step. But for some, you can factorize, so you would actually need to factorize. Then step number two would be to find your lowest common denominator. Then step number three would be to multiply every term. It's very important to underline every term, not just the fractions, not just the whole numbers, but every single term. Not just the things on the left, not just the things on the right. Everything that is in that equation needs to be multiplied by that LCD. And at that point, once you've done your cross multiplying, right, then your fraction should always go away. Then you just need to solve that linear equation that you have in front of you. So if you follow all these 5 steps to the T, you should be good with fraction equations. So on that note, I hope you enjoyed this video. Check me out on the next video where we're going to be doing the juxtaposition between how fraction expressions are simplified and how fraction equations are actually solved. So on that note, that's it from my side. Bye.